Hey, 6th grade, welcome back. Today we are doing lesson 89, diagonals, interior angles, and exterior angles. So let's take this one concept at a time. Let's first talk about diagonals. Well, the book gives us a diagonal, but it's a very wordy definition with a lot of vocabulary words. So let's break it down. Let's first remember what our definition of a polygon is. Remember, our polygon is a closed flat figure with straight sides, right? So this would be a polygon. This is a four-sided polygon. We call it a trapezoid, but remember, because it's four-sided, it could be called a quadrilateral, okay? So our diagonal is a line segment that passes through the polygon between two non-adjacent vertices. Okay, let's think about what this means. Two non-adjacent vertices. Okay, well, we know that this has four vertices. 1, 2, 3, 4. Adjacent would be if the vertices were next to each other. So the adjacent vertices would be like A and B are next to each other, okay? So these would be adjacent. These would be adjacent. These right here would be adjacent, and these right here would be adjacent because they're all next to each other, okay? Our non-adjacent vertices would be the ones that are opposite sides, right? A and C are non-adjacent. D and B are our non-adjacent vertices because they're not next to each other. So then we can talk about what our diagonal then means. Our diagonal is our line segment that passes through the polygon connecting these non-adjacent vertices. Now that we have created a diagonal, we can now look at our first example. Here we have a regular hexagon, A, B, C, D, E, and F, and they want us to draw diagonals from one vertex. From one vertex of a regular hexagon, how many diagonals can be drawn? Okay, let's think about this word regular. Okay, regular polygons. Remember that a regular polygon or regular hexagon means that all sides are equal. Okay, so when you're looking at this, each of these sides is equal to the other. So if we were to pick one of the vertexes, let's say we pick A, and we want to draw as many diagonals as possible, we could look at the first non-adjacent, which would be E right here, and we would connect the diagonal. Then we would go to D, connect the diagonal, and then C, connect the diagonal. And our answer then is we can draw 3 diagonals. Go ahead and pause, do practice A, and then return. Okay, great job everyone. So we have discovered that this hexagon can be divided by 3 diagonals. And when we look closely at these 3 diagonals, we see that it's created 4 triangles. right? We have 4 triangles. 1, 2, 3, 4, right? 4 triangles. So upon further examination of these 4 triangles, we see that every single one of the angles in the hexagon is included inside one of these triangles, right? Angle A, angle B, C, D, E, and F, they're all there, and these triangles all have these angles. Now, if I were to look at just one of these triangles, right, I don't know the measures of each of these angles. I don't know what angle A is, or what angle B is, or what angle C is. But what do we know about triangles? We know that triangles, that the measures, right, equal 180 degrees. And I also know that there are 4 but I've got 4 of these triangles in this hexagon. So while I may not know how the measure of my triangle angles, I can figure out the total of my angles of the entire hexagon. I could say, well, if I have 4 triangles and they each are going to measure 180 degrees, 4 triangles multiplied by 180, that's going to give me 720 degrees. And you can see they've done that over here. So this entire hexagon, all of these angles are going to add up to 720 degrees, because this triangle is 180, this triangle is 180, this triangle is 180, and this triangle is 180, which means that every single one of these angles, when you add them up all together, is going to be 720 degrees. This now gives you a new vocabulary word. The vocabulary word right here in bold is interior angles. The interior angles of the hexagon add up to be 720 degrees. These right here are our interior angles. The angles that open up to the inside, the interior of the polygon. Open to the interior of the polygon. Okay, so now we can do example 2. Maura inscribed a regular hexagon in a circle. Find the measure of each angle of the regular hexagon A, B, C, D, E, F. So the important key word here is each angle of the regular hexagon. Well, we just learned that in our hexagon, because we had our 4 triangles, we were able to say, well, 180 degrees times 4 gave us 720 degrees. And that was our entire hexagon. The entire hexagon, or all interior angles. But now we want to know each angle of the hexagon. Well, we know that this is a regular hexagon. And with regular hexagons, if you remember, that we have all sides are equal, but also all angles are equal. Well, that's good news, because if all sides are equal and all angles are equal, and we know that the entire hexagon, all interior angles together make 720, then all we're going to have to do here is take 720 degrees and divide that by 6. And when we do that, we find that each angle is going to equal 120 degrees. Okay, pause here, go do practice B, C, and D, and then come back to finish out the video. Welcome back, my favorite students. Okay, now we're going to talk about exterior angles. This is our opposite of interior. Remember, our interior angles were on the inside. Our exterior angles are on the outside. Okay, and the way the book explains it is if we were going around the hexagon, we have to make a turn at every corner, right? If we didn't turn, we would just continue going on this straight path, right? So if we're here, we have to make a turn. Then we make a turn, 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 turn. So this area here, where if we were going straight and we turn, this is our angle. From the straight path to the angle. The straight path, if we could have just continued going straight to where our new path takes us. This is our angle. That's our exterior angle right there. Now, the exterior angle is very, very easy to find because how many degrees are in a circle? If I was to go around a circle, there's my beautiful circles. You guys all know I love drawing circles. I hope you catch the sarcasm in my voice there. Well, to go around a circle is 360 degrees. Well, to go around a polygon, is also 360 degrees. So for us to find the measure of our exterior angles, we would have to just take 360 degrees and then divide that by the number of exterior angles we have. So like in our circle, there's no exterior angles, so it's just 360, right? But here we have some exterior angles, and that's going to lead us into our example 4. Okay, so it says, what is the measure of each exterior angle of a regular hexagon? So here's our circle going around our hexagon. We have 1, 2, 3, 4, 5, 6 exterior angles. And like I just said, our circle is 360. If we take 360 divided by our 6 exterior angles, then we know that each angle is going to be 60 degrees. So inside of here, this is 60 degrees. This one would also be, this one would also be, this one would also be, and so on. Each of those is 60 degrees. But to check, to make sure that we are doing this correctly, we can also look at it and say, well, I remember that this makes a straight line. And if you remember, a straight line is 180 degrees. And we also just learned that our interior angle is 120 degrees. So if I were to take 180 degrees and subtract 120 degrees, then I get 60 degrees. So now we have proven this not only from our 360 divided by 6, but taking a straight line and using supplementary angles. Remember that vocabulary word? 2 angles adding up to 180 degrees, supplementary angles, to then find that it is in fact true that our exterior angle is 60 degrees. Okay, and that's it. Go do the last practice set problem, and then you have odd homework for the written practice. Love you, miss you, and see you next time.